Hi, my name is Thomas Edwards. I'm Vice President of Engineering and Development for Fox Networks Engineering and Operations. We're the distribution arm of the Fox Cable and Broadcast Networks in the United States. I operate in the Advanced Technology Group. I'm here today to talk about the challenges and advantages of IP video for broadcast. So I want to talk a bit about how we see the future at Fox in our Broadcast Equipment Center. You know, we think that pretty soon we're not going to have any special broadcast equipment anymore. We're just going to have a data center. It's going to be flexible. It's going to be multi-format for whether it's SD, HD, 4K, high dynamic range, standard dynamic range. It'll be built on COTS IT hardware. It'll utilize software media processing. It'll be virtualized. It'll be operating in a hybrid cloud. So sometimes we'll be running the virtual workflows on our private cloud, and sometimes we'll be operating those in the public cloud. So people ask me, Thomas, how do you stay competitive in this rapidly changing media landscape? So many things are happening. It's difficult to keep up. And the way we think about how we're going to technologically address the situation are two words: flexible and agile. I know a lot of people say these words over and over again. I like to go back to their original meanings. Flexible from Latin flectere, meaning to bend. Able to be easily modified to respond to altered circumstances or conditions. And agile from the Latin agere, meaning do. Quick and well coordinated in movement. That means we've got to be able to bend quickly in order to meet the incredibly changing industry that we are facing. So why IP? How does IP fit in all this? Well, IP provides us great density. It's format agnostic for whether we want SD, HD, 4K, HDR, virtual reality, what have you. Has easy access for software on PC-style servers. And it's easy to multiplex your timing information, your video, your audio, your ancillary data, device registration discovery, comms and tally. It can all go over IP. We also like to think about the economies of scale. So the IABM estimates video systems, methods, and technology, all the professional video out there, is about a $48 billion market. Now that's big, but it's nothing compared to CompTIA's estimate of IT systems, methodology, and technology. That's a $3.8 trillion market. That's an economy of scale you just can't beat. The more things we can put on commercially available off-the-shelf IT hardware, the better we'll be in terms of economies of scale. Ethernet is also getting faster and denser and cheaper very quickly. This is a graph from the Ethernet Alliance showing the roadmap and how Ethernet speeds have improved over time. So this year, the new normal is 10 gigabit Ethernet and 25 gigabit Ethernet in serial connections in single lanes. That's nothing. And 100 gigabit Ethernet in quad lane or QSFP. This is normal. I just bought a 48-port, 25 gig, and 6-port, 100 gig 1RU switch for about $10,000. It's going really fast. And that's not all. Now just shipping are 200 gigabit 4-lane switches and 400 gigabit 8-lane switches. So that's 204 lanes and 408 lanes. And for instance, here's a 16 ports of 400 gigabit Ethernet. That's the equivalent of a 5,000 by 5,000 HD router in not 1RU, but half of 1RU. You can have two of them in 1RU for main and protect. So dense Ethernet routing is already being used on outside broadcast trucks. Many of the new OB trucks, which are very large, are being built around an Ethernet switch. So Fox really got this going with our Game Creek Encore trucks. These are capable of 23 terabits per second of switching. It's over 3,000 by 3,000 3G SDI capabilities within a 28 RU switch. We built these OB trucks for golf, where you've got 18 holes with multiple cameras, lots of replay and monitoring, and it's built around a 10 and 100 gigabit Ethernet fiber capability that gives us density it's really unmatched by SDI. So IP can also lead to virtualization. This is the ability to spin up or spin down our media infrastructure in minutes as we need it to meet the business requirements. You know, sometimes you need an up converter, sometimes you need a logo inserter, sometimes you need a video server. So why have 3 different pieces of hardware? Why not just have one piece of hardware and then load the software as needed? You can move virtual functionality to other servers seamlessly for maintenance. It makes your maintenance windows easier. And we can potentially move workflows between private and public cloud, depending on our business requirements and the costs. So in order to do this, we need standards. Without interoperable multi-vendor standards, none of this is going to work. You can't build a large plant with a single vendor. And that stack includes networking, which is provided by Ethernet and IP, timing and synchronization from the Precision Time Protocol and the SMPTE 2059-2 Precision Time Protocol profile. Media transport, now delivered by SMPTE 2110. Media flow descriptions from Session Description Protocol from the IETF. Registration and discovery and identity from AMWA ISO 4. Connection management from ISO 5. And network control from ISO 6. So let's talk about SMPTE 2110. This standard was a while in coming, and it really took the entire industry to come together and get behind this and support it. But it's here and it's working. It's got a bunch of different sections. One's SMPTE 2110-10, it's system timing and definitions. Another's 2110-20 for uncompressed active video transport. 2110-21, the traffic shaping and delivering timing for uncompressed active video. I'll talk some more about why -21 is really important. -30 is PCM digital audio, which is also AES 67 from the Audio Engineering Society. So the audio industry and the pro video world have come to agree on this methodology for transporting PCM digital audio. 31 is AES transparent transport. So this is for compressed audio methodologies such as Dolby E or AC3. And -40 is the transport of SMPTE ancillary data, your closed captions, time code, SCUDY 35 triggers. So -10, -20, -21, and -30 have all been published by SMPTE now. And those are available in the SMPTE store for download. -31 is currently in SMPTE draft publication ballot, so we expect that shortly. And -40 has actually passed its draft publication ballot and is in pre-publication audit. This could arrive any week now. Obviously, all of these will be completely done by before IBC. So I talked about -21, and this is kind of an important issue, is the ability to pace packets properly through a network. This is one of the challenges that I think we're facing. If you imagine you've got an Ethernet switch with 3 inputs and 1 output, and those 3 flows are converging into the 1 output. If you've got 3 packets showing up at the same exact time, they're going to have to converge, and of course, only 1 can come out at any one point. So there are on-chip SRAM buffers in the Ethernet switches to buffer these up. So they'll get buffered up, and then 1 packet will output, and 1 packet will output, and then you're fine. Then here come another 3 packets. They happen to all come in, worst case scenario, perfectly synchronized, exact same time. They buffer up, and 1 comes out, and 1 comes out, and then you're done, and so forth. This is a well-paced stream. What if you don't have a well-paced stream? So imagine you've got 3 come in, and you know, they're okay, they come out one by one. But then you're kind of expecting the packets here. This is the ideal time they should be coming in, but they don't come in. Something's happened. Maybe there's an interrupt in a virtual machine or something along those lines. Another slot comes by. Now we're 2 packets behind. These senders are really going to have to speed up to catch up. So they start sending, it buffers, they start sending, it buffers, they start sending, and ooh, we have blown up our buffer. That is why you can't have badly paced packet systems in professional media networks. So I'll show you, this is a FPGA SMPTE 2022-6 source. 2022-6 is another type of packetized professional video. And we're looking at the packet inter-arrival times. And you can see that for almost every single packet in this histogram, it's coming in about 7.4 microseconds apart. Packet, 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 packet. This is an FPGA system, it's hardware, it's easy for them to do this. Now I'll jump here to a VMware-based software 2022-6 source. So this is software and virtualized. And if you look at the packet inter-arrival histogram, it looks kind of ugly. And some of these packets have inter-arrival times of up to 2.6 milliseconds. That's about a third of our frame. That's just unacceptable. And if you look over a long period of time, this gets scary. The most packet inter-arrival time we see is 12.6 milliseconds, almost an entire 60p frame. So this is a first generation product. We're expecting these to get better. So SMPTE 2110-21 addresses two different traffic profiles. One is called narrow, or N, and one is called wide, or W. The expectation is narrow is best for the hardware solutions, wide is a little bit wider for software solutions, but still not as bad as what we saw on that last slide. I took a couple of switches in my lab, and we put in some back-to-back packet bursts to see how big those buffers really are on the switch. And you can see for some of these switches, these are mainly 10 gigabit switches, you actually have a very small number of senders that will be able to be supported in a worst case scenario in this switch. Maybe only in the switch number 1, maybe only 22 senders in wide and 90 senders of narrow. In switch number 2, 45 senders of wide, 180 senders of narrow. It's not till we get down to switch 4, which is a slightly newer switch that a vendor provided us, where we actually have the large enough buffers to say, okay, now we can actually handle over 500 wide senders on this Ethernet switch, or over 2,000 narrow senders. So this is a challenge as we're doing IP rollout, is we need to make sure the switches have enough buffers to handle the worst case scenario of packet pacing. I want to tell you a parable. So imagine you have a phone system. You've got phones, you've got phone books, you've got phone numbers, and you've got a phone switching system. Now imagine I take away the phone directory and the phone numbers. My telephones still work. I can still talk over a phone. I just can't dial anyone. And by the way, oh, now I'm taking the dial away. So now I can't do anything with that. And I'm not even sure that I have a connection all the time. That's the situation we are today with just SMPTE 2110. It needs helpers to reveal the full value of the SMPTE 2110 IP solution. And these can come from the Advanced Media Workflow Association, or AMWA, NMOS APIs, where NMOS stands for Network Media Open Specifications. AMWA ISO 4 is discovery and registration. This is a system which allows devices to register themselves on the network, and also you'll be able to discover all the devices on your network. Camera 5 will be able to come in and say, by the way, I'm Camera 5, I'm here, and you know where it is on the network. AMWA ISO 5 is connection management. And this is actually setting up the connections from source to destination. So this is Camera 5 is now going to send video to multi-viewer PIP number 7. But even though the connection is made, we've not guaranteed the bandwidth is available in the network for that connection to work. What guarantees your bandwidth is ISO 6 network control. Network control builds the pipes that can make you sure that that connection has enough bandwidth to make it through your network successfully without any packet loss. All of the AMWA NMOS APIs are available on GitHub for you to download. They're developed in a very agile style, and even during their development, before their release, you can see them on the GitHub website. So Fox has been taking a very strong effort to try to move all of these standards forward. And we've been using our Woodlands facilities lab to perform different interops, such as this pre-NAB interop, where multiple vendors can come together. They can all try out to interop with these different standards. And at IBC of 2017, you saw the results where 50+ vendors came together. They were all successfully interoperating with SMPTE 2110. Many of them were also interoperating with AMLA ISO 4 registration discovery. So who's doing 2110 out there? Well, I'll say Fox is doing 2110 in our network plant. I'll admit we're using it mainly for monitoring right now, but we're doing that now. Who else is doing this? BBC Wales has a new facility, will be open in 2019 with over 1,000 people doing 2110. La Nouvelle Maison de Radio Canada, the CBC folks, are building a new plant in Montreal. Also will be going on air in 2019 using 2110. The new NBC Universal Telemundo HQ is going to be opening up in Miami fairly shortly here in 2018 using 2110. And already in use, the Timeline TV's UHD IPOB truck is already in use, doing 4K using SMPTE 2110 over IP. So it's real and it's being deployed. So let me give you a couple of last thoughts on IP. There are immediate benefits from IP in terms of Ethernet density over SDI. You get that right off the bat. And there are already OB trucks and some plants which are taking advantage of that density. We have the promise of automagical registration discovery of broadcast devices, so that I don't have to use an Excel spreadsheet to figure out which cameras are connected into which SDI router port. Slightly farther down the road is the promise of agile, software-based, virtualized cloud live media processing solutions. This is still, I'd say, something in its infancy. We're just beginning to see these software applications come on. We're just beginning to consider how to virtualize them. Right now, public cloud provides no quality of service, so it's guarantees, I should say. So it's not really practical on public cloud, more of a private cloud solution in the short term. But I tell you, it's going to be a big change for vendors from SDI. All of the IP products we see are going to be in what I'm going to call the early stage. The vendors are still trying to get their sea legs on this. They're deploying products. They need some fixes sometimes, but they're getting better and better, and I'm very impressed with the speed that they're moving. But again, it's still early days. The NMOS API implementations are really lagging 2110, though. I'm encouraging all vendors to really hurry up and adopt, especially ISO 4 and ISO 5, as fast as possible, because that also provides real value from IP you just can't get from SDI. There's no such thing as registration discovery over SDI. There's no such thing as connection management over SDI, unless you're talking about plugging cables together as connection management. But I tell you, the hardware to software change is going to really offer the most value to users. But it's also going to be the largest challenge to vendors. So all I can say to those of you in the audience who are vendors today, hold on to that change from hardware to software.
So I got a couple questions. So a lot of our audience today are integrators, are people that are out implementing this in facilities. And a lot of them I talk to are either skeptical or afraid at this point. What words of wisdom could you give them to either push them into it, or would you tell them to hold off a while?
I think it depends on the size of your plant. If you're building a large new plant, I think it is worth it to be one of these first adopters and build it with IP, because you're going to feel pretty silly 5 years down the road if you're building a new plant today and you've built it in SDI and you've got to completely redo everything. I don't think you're going to want to do that. On the other hand, if you're a small operation, if you're maybe a small market television station, maybe the move to IP is not that important for you right now. Or maybe you might want to use one of these compressed mode methodology IPs as opposed to uncompressed. It depends on your business requirements. So I will say it is early days. It's a great time, I'd say, for large greenfield builds to go IP. I think other people they have to consider. You know, it is true. I think John Maya from Magic Communication says it is also the golden age of SDI, right? It's also very affordable too, and it's easy to do. You're just not going to have all the capability that IP can give you. And it really, I think, depends on the size of your plant and the operations you're going to have to do.
Now you mentioned cost. Is there a value proposition in terms of cost of moving to? Obviously, there's a cost to the switches, there's a cost to the cabling, but you'd have a cost in a matrix, you'd have a cost in your copper. Is there a cost value proposition in transitioning over to IP?
Well, I'll say there is no sane way to build an SDI solution that's much over 1,000 by 1,000. So if you're one of those big plants or a big OB truck, you just don't really have a choice. If you want that type of capability, and a lot of people need it because monitoring is becoming very important for the large number of feeds, especially in OB trucks, there's no other sane way to do it, with the especially with the density that IP, and really it's an Ethernet density question, with the density of Ethernet switches, you just can't beat it. If you only have 100 devices, it's less of a density advantage on day one.
Got it. So it becomes a cost factor at that point.
But I'll say, you know, the thing about Ethernet, I can tell you, no matter how much it costs this year, I can tell you it's going to cost half as much next year. That's going to cost half as much the year after that because of that economy of scale that we're talking about.
Again, as I said, we've seen SDI do the same thing. Like it's sort of stabilized and plateaued. I don't see it dropping as fast. But I would say, at least with Ethernet, the bandwidth is increasing. So you mentioned earlier 100 gig. We talked to folks that are already looking at 200 and 400 and planning out several years down the road.
Oh yeah, terabit is coming after 400, that's for sure.
Yeah, absolutely.
Well, and I'll say, you know, the challenge here is SDI it's a single flow over SDI, and there's no data flowing over it. It's just a single connection, and that's the difference. A 400 gig connection could have 400 HD flows. So as the port speeds increase, you're able to compose more and more of these flows together, and that's what really gets you that density value.
Got it. Now, you mentioned earlier, you know, you guys at Fox moved a small portion, it seems like, of the production or of your plant. What were the factors in moving that, or why make that choice now to do that part of the business in IP?
So we had an opportunity to purchase an Ethernet switch at a reasonable price. And what we did was we took all of our monitoring cross points off of our SDI router and put them on that. And that freed up a lot of SDI, and frankly right now we're okay for a while. You know, I think we're, as we're looking at new opportunities, I think we'd be putting more of the air critical paths over IP, but for the short term we're okay. So it's kind of nice, we've got all of this monitoring, and it's really flexible, and it's all over IP. So that's a good opportunity for maybe people who don't have a complete greenfield build, but they're a little scared. They're scared, oh, should I really put my air critical feeds over this? Start with monitoring, and then if the monitoring works, if you're watching it as we have over a year or two and nothing's messed up, then start putting your air critical paths on. And that's actually exactly what we're doing right now.
So what do you think the adoption rate on this is going to be? I mean, if you were looking down the road, do we see is this a 3 to 5 year for most of the larger broadcasters, or are they seeing this as coming much faster for them?
Well, I think within the next 2 or 3 years, again, large greenfield builds will be IP. There are no two ways about it. I think for retrofitting, I think as people look at their next maybe 4 or 5 year plan of retrofit, they'll probably begin to do that. I wouldn't be surprised to see it happening within that kind of timeline.
When you guys moved the monitoring over, what were were there problems? What were the bad things that came out of this, or the learning curve in this that said, okay, this isn't ready, or here are the hurdles that we had to overcome?
We were early adopters, and I think a lot of the issues is becoming familiar with Ethernet technology. So our excellent engineering staff knew a lot about crimping coaxial cables. When it came to cleaning optical fibers, that was new for them, right? So there were a lot of new things they had to learn about how to deal with Ethernet and how to deal with IP. Subnets, IP addresses, and also the control system, I think had some hiccups at first, but over time we're able to get it fine. It's working perfectly today.
We were laughing earlier about the plethora of MXF formats out there, and do you see this continuing to stabilize, or is there going to be more splintering of formats as we move into IP? I mean, you talk a little bit about some of the lower end compressed formats, what else is out there that you're seeing on the horizon that could create a more complicated environment?
Well, in Fox Engineering, our goal is to buy stuff which is standardized.
Yeah.
Because we like the fact the standardization process tends to bring out any unknown intellectual property issues. It also makes sure that all the vendors who we really use and depend on are going to be in the room as they're coming up with this, bringing all of their knowledge. You know, these vendors, of course, they've been doing real-world implementations all over the world of large plants. So when they say this standard isn't quite right, we need to change it, we believe them. So it's nice to have all those people, that think tank in a room working on this project, but then we also know that we can do these interops and that we can swap out vendors. You know, no plant our size is homogeneous. It's not single vendor. You just can't literally do it. We have to be multi-vendor, and from a financial perspective, we want to have the best deal on every product we bring in, right? We don't want to pay any more than we have to. And sometimes if we find a vendor unresponsive, we've got to swap them out for a more responsive vendor. Thus, standards are completely important to us. So 2110 to date has been an uncompressed standard through 2110-20 for uncompressed video. SMPTE is working on 2110-22, which is a framework to bring in some compressed methodologies into 2110. And I recognize there are a lot of people out there who maybe they're a little more happy at the 1 gigabit Ethernet level rather than the 10, although I think the price differential will be very small soon, but I can understand that.
Yeah, I mean, I would say even 2 or 3 years ago, that price on a 10 gig port was massively higher than a 1 gig port now, but that's come so far down. And and I guess that's Moore's Law, right? As we hit 200 and 400, 10 is going to get smaller, 25 is going to get cheaper, 50 will become more affordable. It just sort of all blends at that point. Mm-hmm. From your perspective, would you coach people right now to just do it or to sit out just a little bit longer?
Well, I think it depends who you are.
Okay, so we go back to that.
We gotta go back to that.
But even just to jumping in and testing the waters, is now the right time to really do that?
I mean, I think it's a good time to begin to become familiar with what's out there. Certainly, my lab, we try to bring in every vendor product that we can find that's IP. We try to bring it through the lab, we evaluate it, we take a look at it. We try to give them useful feedback because they do need some feedback. Again, some of these products are a bit early right now. There are no two ways about it.
Okay, so last one. Do you see the end to SDI down the road, or will it always be present in our facilities?
Well, do we see the end of analog in our facilities?
I wish.
I still run into people who have analog plants. They're like, you know what? We're SD. We're producing maybe for an international audience, and we don't have enough HD sets, and we're happy with analog. So that's still out there. That's not going away. And SDI is still out there too. So I think it's one of those things. I'm sure you can still find people who write in cuneiform, in hieroglyphics. Those people are out there. I think it's going to be a fade, but I do think we'll get to the point where almost all new professional video, you're going to say, I've got 4K, I've got 8K, or high dynamic range, or who knows, 120 frames per second, and I just needed to go IP because it's the only thing that makes sense.
Well, I guess the interoperability of that switch, as long as you've got a switch that's got a big enough backbone, you're not going to be swapping it out like you would that SDI matrix, right? That's going to be consistent all the way across.
IP does not care what you send across it. You can send anything across IP.
I guess that would be the biggest cost factor right there, then, is building a foundation that can grow well beyond your current needs from that perspective. Okay, so looking outside of Ethernet, what technology right now excites you that you're seeing kind of on the horizon?
I really love high dynamic range.
Nice.
I was just saying, I recently got to see a SpaceX launch from Vandenberg. I'm looking up at the flames coming out of the rocket. I'm like, you know what, that looks a lot better in real life than it does on television. I'm realizing that we can't reproduce that really intense red that's coming out. It's just not a 709 color. It's not in SDR. I really like high dynamic range when it's done well. So I think that's very interesting.
And I've listened to people who have watched 4K and then watch high dynamic range, and they feel like HDR has made a better impact than 4K. At a distance, you don't tell the difference in 4K. At a distance, HDR still looks amazing.
Yeah, I agree.
From the screen.
Well, and the other problem is that a lot of people start with a 4K acquisition and they compress the heck out of it, and it's not 4K resolution. Even though you have 4K pixels, it's not 4K resolution. And you do have to make sure you've got 4K lens, 4K imaging system, And so there's lots you need to do a really good 4K production. Whereas, again, HDR though is also a challenge. It's for the digital cinema people, it's not that hard. They shoot something and they spend all day turning knobs, making it look beautiful. But in live sports, we can't do that.
Yeah.
So in live sports, figuring out how we produce simultaneously standard dynamic range and high dynamic range, and they both look good, recognizing 99% of our viewers today are standard dynamic range. That is a bit of a challenge. The industry is coming up with some kind of ad hoc solutions to it, but I think that we've not seen the optimal solution yet. I'm still waiting.
Is the adoption with HDR need to happen more in the consumer world before it's really going to take off? Because it was like 3D in the early days. Everybody can make 3D, but there were no TVs to watch it on, so it was really just a cinema-only application.
I don't know. I think HDR television is actually, I think the consumer televisions are actually a little bit ahead of our distribution capabilities. I think it's more of a business problem. And we had this with stereoscopic 3D. We had a certain sports game, I won't mention, that we did in stereoscopic 3D, but we also carried on our broadcast network. But the stereoscopic 3D wouldn't go over the broadcast network. It had to go over a MVPD of some sort. Our broadcast affiliate said, "Why are you giving this game away to that MVPD?" And we're like, okay, that was the end of stereoscopic 3D for us. And the same channel cannibalization problem happens in 4K. So obviously it's less of a problem for OTT providers because they don't have an incumbent channel to cannibalize, right? It's a little bit more challenging, I think, for cable networks. It's a little easier for them than for broadcast networks. For broadcast networks, it's very hard to go around the broadcast methodology. Of course, ATSC 3.0 will bring us high dynamic range, so we do have some hope moving forward, and Fox is a participant in the Phoenix test market, which is coming on air right now. We'll hear a lot more about ATSC 3.0 this NAB, but obviously HDR is a major part of that for us.
But I guess the MVPDs are really the best hope for a lot of these newer technologies because they're like the Ethernet, unrestricted in terms of interoperability. They don't have to worry about the broadcast method. They just open up an IP port and let the data flow. And they're able to get to there faster, unfortunately.
Yeah, it is, but also they've got to have a business to support that, right? So it's one thing to say, I'm going to put up one 4K channel that's like a demo and I'm going to showcase da-da-da. I'm not going to pay anybody any real money for it. It's another thing to say, I've got a 4K channel that has the same number of viewers as, sorry, a 4K or a HDR as my SDR HD channel, right? Without that audience, you can't monetize it. Without money, there's no business, right?
All right, amazing. So thank you so much for being here. Really appreciate it. To the outside audience, this has been Techsplanation. We thank you for watching.